Hey guys, it's Mr. Win, and we're going to talk about graphing polynomials. So we've been doing polynomials this whole unit, and now we're going to get into graphing them, like kind of sketching them, just getting the general idea, not really, being exact, but at least we can tell how it behaves, okay? So our essential question is, how do I graph polynomials? All right? So there's two things you need to know about polynomials and how to sketch them, how to graph them, right? You got to know how it ends, right? Both directions, how it ends the end behavior, and you got to know your zeros and if there's any multiplicity. Okay, and I'll explain what that means in a little bit. But let's talk about end behavior first. Okay, as an example, all right, you don't have to draw this, but if you have a graph, okay, say a quadratic, it ends, going one way, it goes the other. So this one goes positive up, positive down, right? That's what end behavior is. In dealing with polynomials, okay, you look at the highest degree, okay? So as an example, your highest degree, all right? The highest degree, your highest term, right? Your leading coefficient, all that, the main one in front, okay? If it's even, that means if your degree is even, that exponent, okay? Highest degree exponent, okay? If your highest exponent is even, right? If it's even, then that means when it goes one direction, like say it's positive to the left, it can do whatever it wants, but it's going to end up positive as well. Okay? If it's negative, all right, and then it's going to end up negative as well. Okay, so this is positive. Okay, positive. I can't spell positive, but V, all right, and negative. Okay, and what that also means, how to tell between the difference between those two. Okay, look at your leading coefficient. So whatever your highest degree, your leading term is, that number in front, is it positive? Then it will start positive and go positive. Is it negative? Then it goes, starts a negative and goes, ends up being negative, right? Looking at the leading coefficient, so the number in front, if it's positive or negative, okay? But if the degree is even, it ends in the same direction. Okay, so that's why you look at your leading term, and then look at the exponent, even, right, ends in the same direction. Positive, starts up, ends up. Negative, and starts down, ends down, okay? And if it's odd, you can probably guess. If you look at your leading coefficient, and it's positive, you will start negative, okay, but kind of the opposite. It ends the opposite direction, right? You start negative, but you end up positive, right? Notice how the end is positive, right? Going to the right, reading left to right. If your leading coefficient is negative, start positive, end up negative, okay? So we can kind of tell, what that graph will look like and looking at the, end behavior, okay? Looking at the degree, your leading coefficient and all that, leading degree, okay? So say example 1, okay? What I mean when I say leading term is the term with the highest degree, okay? The highest degree here is 4, all right? Not the 2. Not, the 5 doesn't even have a variable on it, right? So the highest degree is 4. Yeah, that means it's even. All right, we're looking at the even graphs. And you also want to look at what's called your leading coefficient. So the number in front of that. And technically here it would be a 1. So your leading coefficient is 1, which is positive, right? Positive 1. So it's going to start positive. Whatever it does, going to end positive because it's even. All right, look at example 2. Where's your leading term, right? Happens to be in the front. It has the highest degree of 3, right? Your exponent, the highest is 3, okay? And the number in front is technically a negative 1. So two things to know. We have a degree of 3, which is odd. And we have a leading coefficient of negative 1, which is negative. So that means, okay, we're going to end up negative, but it's the opposite direction. So we got to start positive. Forget that. I haven't showed here. All right, it's going to start positive and then end up negative. Okay, that's end behavior, just the ends, right? Now we're going to talk about where and, when it curves, okay? This is what's called multiplicity. So we've done synthetic division where we get terms like x plus 1, x minus 2, whatever, x plus, let's say 3, okay? But sometimes you have more than one of those, those factors, right? Well, that's what's called multiplicity. So say this, you see x minus 2 twice, okay? Or say if you see x plus 3 3 times, okay? Those are different. They're different. They're multiplicity, right? Those zeros are seen more than once, multiplicity. So if it's even, like say the x minus 2, okay? X minus 2, it's even, right? You can tell it's even because the multiplicity is squared, right? That 2 tells you it's even. So you can guess if it's an odd number like the 3, it's an odd multiplicity. The only other case, that special case, is if there's a 1. That means if there's no multiplicity at all, that's actually 1. So I know technically 1 is odd, but think of it as having no multiplicity. It's just 1. Okay? This means when you graph that 0, okay, when you graph that 0, if it's even, it's going to go down to that 0. It's going to touch it and go back up in the same direction. Think of it's even, you know, starting positive, ends positive, so it's going up. It's going to go back up. It's going to touch it, and it's going to go back up. So here, we're touching, okay, when the multiplicity is even. So when you look at x minus 2 squared and you're trying to graph that 0, it touches and goes back. If it's odd, and you could probably guess, when it goes to that 0, okay, let me draw this a little cleaner. It's going to bend, right? It's going to bend. It's going to touch it and then go back the other way. It's going to bend but cross, okay? So it's like increasing here, right? Or, well, decreasing here and then increasing. So it's going to bend and cross, okay? So even, touch, bend and cross for odd. And if it's 1, okay, it might go to that point, but then straight up cross, okay? If it's increasing below it, increasing above it, it's only crossing, okay? So now let's actually do an example where we graph those, okay? So to recap everything, don't forget your end behavior. Let's do end behavior first, all right? Find the highest degree. Well, remember, all of these factors are being multiplied. So the way to find your highest degree, well, look at all your exponents, okay? Look at all your leading coefficients of each, right? And multiply it. So like say here, this is an x, right? This is your leading term here. Let me color this, right? These are your leading terms, the x's of each parentheses, right? But notice here, it's being multiplied by 2. So this is squared, right? Your leading coefficient here is being multiplied to the 3rd power, so it's cubed here, right? So really, your leading coefficients of each are going to be x, x squared, and x cubed. And if you multiply all those together, really you're just looking at all the exponents. You've got 1, 2, and 3. So 1 plus 2 plus 3 is 6. Okay, let me move this down just a bit so we're in line. Okay, so your highest degree would be 6, right? Because think of your leading terms, 1, 2, and 3. 1 plus 2 plus 1, 2, and 3 is 6, okay? But your leading coefficient is each of those numbers as well. So what is the number technically in front of those? Well, you got a 1 here, a 1 here, and a 1 here. This is easy. Synthetic division, we're used to getting where it's just 1 in front. You might end up with one expression, then maybe it's 2, maybe one of them is negative, it might change it. But the leading coefficient of 1 of each is 1. And if you multiply 1 times 1 times 1, it's still going to be 1. It's still going to be positive. So we know 2 things. It's an even, right? It's even, right? So it's going to look something like this, even, but end up positive, okay? That's kind of idea. Remember that, that's the end. So we're going to start positive, okay? Now look at your multiplicities, all right? So first off, your zeros, okay? Your zeros of each, x plus 2. If I take x plus 2 and put it equal to 0, this is going to be negative 2, right? So one of your zeros is negative 2. And if I take the x minus 2, right over here, we're taking each factor, right? The 0 would be positive 2, right? Kind of taking the opposite, right? And if it's x plus 5, the 0 would be negative 5, right? Which is, you know, putting it equal to 0 of each factor, right? But what are the multiplicities of each? Okay, so what are the multiplicities? I was going to say multi. All right, the negative 2 right? Remember your first term here. The negative 2 had a multiplicity of 1. Your second one had a multiplicity of 2. And your last one right here, your 5 multiplicity of 3. All right? Put it all together. Okay? So here's my zeros. Okay? We have different zeros. We have zeros of negative 2, negative 3, negative 4, negative 5, and positive 2. Right? Those are all our zeros, right? So we know it's going to cross at all those points. We know the degree is even, so we're going to start positive. All right? And then at the multiplicity of 5, we're doing this first. At 5, that multiplicity is odd, so we're going to bend and cross, okay? And then at negative 2, multiplicity was 1, so we're going to go up, cross it at negative 2, okay? Stays the same, all right? And then the last one, the multiplicity of 2, at 2, we're going to bend. All right, we're going to actually come up over here, touch it at 2. Let me draw that a little bit better. Okay. From here, we're going to go up. However it goes, we're going to touch it at 2. And then end up back positive. Okay? So we checked off a couple things, right? It's even. That means it goes in behaviors both directions, right? Or even. It's positive. Start positive. Okay? It touches 5. Multiplicity of negative 5 is 3. It bends and crosses. Multiplicity of 2 is just crossing. And then multiplicity of 1, or even, sorry, excuse me, is even, is just touching. Okay? And now we have a good sketch of our graph. And here we go. That's it. All right? Thanks.